Hello, this is Mr. Zanolletto. I'm going to look over a couple of the topics we did this unit, specifically 11F and 11G. 11F asks, can three side lengths form a triangle? 11G asks, what is the range of the third side? I think these are really two topics that are really related. They're related very closely to one another, and that's why I've chosen to go ahead and discuss these two together on this video. 11F, it asks, can three sides form a triangle? Well, if you have a 3-inch side and you go ahead and you connect that to a 4-inch side, turns out that yes, 5 inches can make up that third side, and you end up with 3 inches, 4 inches, and 5 inches, and it successfully did that. And if you look at what our our rules were trying to say was that the 3 inches plus the 4 inches had to be greater than the 5 inches. And here, in fact, 7 inches is greater than 5 inches. So the rule worked, and in practice, we've shown the triangle works. 3 inches, 4 inches, and 8 inches, on the other hand, if I put 8-inch segment down here, and I draw 8 inches, and I go from one end and try to draw a side, is there any way a 4-inch side and the 3-inch side could meet up to create the other side of, the other side, there we go. If these two, if I try to even swing them down, they're still going to be 1 inch apart, because 3 inches plus 4 inches, the 3 inches plus the 4 inches compared to the 8 inches, 7 inches is less than 8 inches. So it is not more. And since it's less and not greater than, the two aren't greater than the third, it can't make a triangle, because these two sides can't bridge this length. Here, if we looked at this one, this 5-inch span, the 3 inches and the 4 inches clearly could span over the 5 inches. They still had 2 inches left. Well, they still had quite a bit of room to create a triangle. Here, these two do not bridge the gap. They can't bridge that 8-inch span with 3 inches and 4 inches. And therefore, they come up short, and therefore, no triangle. Here, yes, triangle up here. So that's 11F. And that same idea of spanning areas and stuff, lengths, we're going to look at what's the range of if three sides, if given a 3-inch and a 4-inch lengths. Well, if I have a 3-inch here length and a 4-inch length there, that third side, if I make it really obtuse, it's pretty skinny. It's not quite as skinny as absolutely possible. But if I look at that and then I try to measure it, this was 3 inches and this was 4 inches. I had created it before I started making this video here. And I had 3 inches and 4 inches. How far apart are they in that case? And it looks like they're just a little longer than about 6 3/4. Roughly speaking, yeah, 6 3/4. So that's 6 3/4 inches. So they're just a little bit less than the sum of that. And if I go ahead and compare this is about 1 1/8 inch long. When I make them sort of fold on top of one another. I get 1 inch, 1 1/8 inch long. So these are both triangles that would fall under that idea if we add the 3/4, 3 and the 4, or we subtract the 3 and the 4, we get 1 and 7. These two measurements fall between 1 and 7. The third length has to be greater than 1 inch, but less than the 7 inches. So in the end, what is the range of that third side? It falls between the difference of the two values and the sum of the two values. So we subtract, and that's what gives us the range. What is the range of the third side? It falls between the difference and the sum. X would have to fall between those. It's going to have to be greater than the difference, less than the sum. So hopefully these explanations of why 11F and 11G gave us these rules that we did at the beginning of this and was actually taught during class. We were given these two, that better explains why 11F and 11G work. Can three side lengths form a triangle? The two small sides have to add up to more than the third side. And what's the range? If you subtract the sides, it has to be greater than the subtracted sides, but less than the added sides. Thank you.